Okay, here we go. All right, today we're talking, this is our second installment of 2.3. We're going to deal with increasing and decreasing intervals. We'll talk about constant intervals. We'll talk about maximum, relative maximum, absolute minimum, relative minimum, all that fun stuff, all jam-packed in one video. Aren't you lucky? So our learning targets for today. Okay, we already did our test for symmetry in the last video. We're talking about minimums and maximums, like I said, and increasing and decreasing. Okay, here we go. First thing we'll talk about increasing. All right, as our x increases, our inputs increases, our outputs also increase, creating a positive slope. Okay, so we're talking about lines that are going up and away. Okay, decreasing. I'm not going to look like that. Decreasing means a negative slope as our inputs are increasing, our outputs are decreasing, something like that. Constant, as x increases, y stays the same. And that's not straight. That's going to bother me. Is that going to bother a lot of you? Probably. There you go. That's a constant line right there. All right. What else? The slope of this line, creating a slope of 0. Remember, horizontal lines have a slope of 0. Okay. So let's look at some samples. Let's try to identify increasing and decreasing intervals. Here we go. Looking at this first graph here, all right, as I'm reading from left to right, okay, I want to tell if our function is increasing, decreasing, or constant. Well, if I read from left to right, it looks as though my function is going up and away. As I go from left to right here, my function is increasing. And it looks like it's always increasing. So I'll write increasing always. All right, here on the second one, okay, as I go from left to right, it looks like my function is going down, 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 down. So it's decreasing always. Okay, this bottom left one, a little different, right? It's a little different. It looks like probably a cubic function, disco man action going on here. So as I go from left to right, here my function is coming from negative infinity. It looks like it increasing to this point here. Then it starts to decrease a little bit. Then it starts to increase a little again. So let's first identify the increasing intervals only. All right, increasing only. So first, we'll call this point right here, we can call that A. So I'm increasing from here to A, and we can call this point here, we'll call it, you guessed it, B, and I'm increasing from B off to forever. So my increasing interval, let's make, that's going to bother me. Let's undo that. Okay, so my increasing, down here, look, down here I'm negative infinity, so I'm negative infinity to A, pick it back up at B off to infinity. So that means I'm decreasing right in the middle, in between A and B. So my decreasing interval is from A to B. I have a negative slope right there. Okay? Let's look at the next one here. Right there. Okay? As I move from left to right, here we go, left to right. Now this is a little funky, all right? Some might argue this is constant, okay? Some might say that. I'm going to go ahead and just say that it's increasing, that it just sort of tails off and slowly goes over here, that it doesn't flatten out, okay? So we'll say it's increasing. We'll say it's increasing. Bless America. There we go, increasing from negative infinity to this point. We'll call it C. Okay, notice how I'm not, when I'm talking about A and B here, I'm not including those values. They're not included, all right? They're not including that X value, okay? And then it looks like I'm not, what am I doing here? I'm not decreasing here. There are no decreasing intervals here. What am I doing here? I am flattening it out. I'm going constant. So I'm constant, we'll abbreviate that CON from C to infinity. Wow, isn't that cool? That's pretty neat. All right, last one. Here we go. So it looks as though if I'm looking from left to right that I am increasing. Here I'm getting bigger, and then all of a sudden at this point, we'll call it, you guessed it, we'll call this point D, I start to decrease. So I'm increasing from negative infinity to D, and I am, decreasing from D to infinity. Okay? So that's increasing, decreasing, constant. All right, we're going to dive some more into that a little bit. All right, let's talk about relative maximum, minimum, etc. Okay, first of all, relative maximum. A relative maximum, what is a relative maximum? So a relative maximum is a y value. What the heck is going on? And we are back. All right, I had a little freezing action going on there. But that's all right. We got a battle. So let's talk about relative maximums. A relative maximum is a y value that's greater than all other values on an interval. Okay, we're looking at y values that are the greatest point, that maximum, to everything that's around it. Okay, it may not be the actual maximum of our entire function, but relative to the points surrounding that point, all right, it is an actual maximum. Maximums in general, okay, in general, maximums occur. Holy buckets, here we go. And when you switch from increasing to decreasing, that's when a maximum occurs. Okay, there's that little, like a little hump right there, right? That would be our maximum. Okay. We also have relative minimums. Okay, similar to the maximums. All right, all other values around it are larger relative to the whole function or relative to that area. All right, that's a minimum. Okay, that could be something like this would be a minimum. All right, there would be a minimum. That goes from decreasing to increasing. Okay. And we have these things called absolute maximums. So absolute maximums are the actual maximum of your function. Okay, and absolute minimums are the absolute minimum of your function. All right, that means that it is the highest possible point on your function or the lowest possible point on your function. So these two examples I actually drew, this would be an absolute maximum. Okay, and this would be an absolute minimum as well. Okay, I don't. Yes, for sure. Okay, so let's try to identify some of these things. So let's identify all of our maximums first. Okay, or if there's more than one. Okay, so here there's a little pause. Remember, maximums go from increasing to decreasing. So I'm decreasing here. So now I'm increasing and I decrease. So here we go. So there's a maximum. So now we have to decide, all right, is it the absolute maximum point of our function, or is it relative, or is it a relative maximum? Is it a maximum to all the points around it? Well, if you look at our function, this function is going up, up, and away in both directions, so it cannot be the absolute maximum. This would have to be a relative max. A relative max. Okay. Let's identify our minimums next. Here's a minimum. And here's a minimum. Okay. Minimums, remember, happen when I go from decreasing to increasing. Decreasing to increasing. Okay. First, let's look here. Is this the absolute lowest point on our graph? It is. So this would be considered an absolute minimum. This here would be considered, since it's not the absolute, it has to be a relative min. Because relative to all other points around it, it is the lowest. All right, let's look at the top right here. Let's identify maximums first. So am I going from increasing to decreasing? Yes, I am. It's about right here. Okay, so that would be, is that the absolute max or relative max? Well, relative to everything around it, it's maximum. If you think about your function as a whole, it's actually the highest point on your graph. This would be considered an absolute max. All right. Again, let's identify our maximums first. Okay. Is this a maximum down here? No. This is a maximum point here. Good. This is not a maximum. This is a maximum. Since it's not, there aren't arrows here, you can assume that the function stops. Okay. So here, is this absolute or relative? Well, looking at our function in general, or as a whole, this is the highest possible point on our graph. So this is actually an absolute max. Okay. This down here, this bottom point, would then be considered a relative max. All right. Let's look minimums next. I have a minimum here and a minimum here. This is not the lowest point on our graph, except it is the lowest point in that relative area or general area. So this would be a relative min, and this would be an absolute min. Okay. Let's look at our last one over here. Okay. So maximums first, increasing to decreasing here. Let's look around it. It's relatively the maximum. Is it the absolute maximum? How can you tell? Well, no, it's not, because this part of our graph is going off to forever, to infinity. So this would be a relative max. If this was stopped here, it still wouldn't be our absolute max, a relative max. Okay, so now we're going from our decreasing to increasing. So this has to be a minimum. All right. Well, it's not the absolute minimum, because our graph goes on to negative infinity, so it's just a relative minimum. Okay. When identifying your maximum minimums, x values tell us where that maximum minimum occur, and the y values tell us what the minimum or maximum value is. X values are where it occurs, y values tell us what it is. Okay. So let's identify increasing, decreasing, and constant intervals. Okay, so let's look at, this is, our function seems to be increasing here. So that is increasing. Oh my goodness, increasing from 0 to 1. I know my chicken scratch is going great today. And then it's increasing there as well, so from 2 to infinity. Decreasing here, so from negative infinity to 0. Remember, we're not including it. And we are constant there, from 1 to 2. Okay. Now identify any maximums or minimums. All right. Is there a maximum here? There is no max. There's no max. No max. This would not be considered a relative max here, all right, because it hits it twice. It's double. Okay, so it's not relative. If it went like down like this and then back up, then it would be considered a relative max. But since our function just goes to constant, all right, it's not a relative max. Remember, relative max go from increasing to decreasing. We're going from increasing to constant here, so it can't be a maximum. We do have a minimum down here, and that is an absolute min. Oh, I'm running out of time. At x equals 0 with a minimum value of 0. All right, so I'm kind of running out of time here. So what I'm going to do is I'm going to make a second part to this video, just so it'll go over this, all right, and we'll do a couple examples as well, okay, just to give you the instructions on how to use your graphing calculator. So look for part 2 to come. All right, but great job.